Okay, so last time we talked about how you can use many different flavors for your neural network. So you could have input layer and then many hidden layers and then an output layer. That's generally how it goes. Um, and last time I said that you can actually customize this to be whatever architecture that you want. If you want this one to not have two nodes but also have four nodes, or have 100 nodes, whatever you want, you can have that. But I want to point out to you that there's two things that you can't change, two layers that you can't change. And that is the input layer over here and the output layer over here. And these two cannot be changed because that is relevant to your task, right? This neural network, applying the neural network is a means to an end to do the task, but this within itself is a definition of the task, that you only get three inputs for this particular task, and you only have one output for this particular task. So you can't change that, but you can change all of the hidden mechanisms that work within the neural network. And so now in this video, I wanted to show you a couple of real examples of data sets that are considered like toy data sets or experimental data sets in the deep learning, machine learning community, and introduce you to like what data sets look like. I've been talking about how data sets are like things that you know, and then you're trying to use that to predict the things that you don't know. And so what does that actually mean? So in this first example, we have a flower example where it's like I think it's an iris flower data set where you have like different flowers and you're trying to figure out, given the information about a flower, which type of flower is it? And so I think the stuff that you're given is like the measurement of some measurements about the flower in terms of like centimeters or something like that. And you're given all of this information about, sepal length, width, petal length, and width, and you're trying to predict the species. Is it iris, this, iris that? I'm not an expert on plants, but that's essentially what you're trying to do. So I want to just notice that these right here are the features, right? These are the features. And then this is the label, the one thing that you're trying to predict. So this is a many to one problem where you're trying to use a lot of things and then predict one thing. And so that's one of the things, right, that to notice. And then the other thing to notice is that there are only finitely many possibilities that the species column can have. And therefore, it's a discrete problem, a classification problem. So this is actually a classification task because of that. And so let's say you have these inputs, what are they? Four inputs, and you have one output. So since this is a classification task, what you could do is you could combine all of these together and determine whether or not it is some sort of class. Now, you might be asking that here you can see that there are, I think, at least three different types of species over here. So how do you determine whether or not something is of a particular species? Well, what you can do is you can expand this to not just having one output, but actually having three outputs. Okay, so this, let's say, has three outputs, and this is our neural network. Um, and what I can do is I can have this be a classification for whether or not it is of the first species, whether or not it is of the second species, whether or not it is of the third species. And so I get a probability for all of them. And one thing that I can do is maybe take the highest probability. So let's say that this is 0.99, this one is 0.7, this one is 0.1, right? And so out of all of these three, 0.99 seems to be the highest. So I might classify this as the first type of species. So we'll get more into how all of this works later on. But I just wanted to introduce these data sets to you first. Here you can see a breast cancer data set where you're given a couple of things about a particular patient, and what you're trying to measure or trying to predict is whether or not their breast cancer is a malignant tumor or a benign tumor. And so this is the target feature, and this is what you're trying to predict. It's a binary class between like, is it malignant or is it not malignant? The age of you get the age of the person, a couple of things about their health, and this is what you're trying to predict. Um, Here you can see a similar thing. So once again, this is a classification problem, right? Because you can only have two options. It's a binary option for the output. But let's say um, over here, let's say this is a measure of something, so that's an integer, and therefore it can range between. Oh, actually, it says over here it can range between 1, 2, and 3. This one is yes or no, left and right, up and down, whatever. So these are all different like features which are also categorical or basically discrete. They can only take on a finite number of values. Over here, you can see a housing data set. And so this is like, I think, houses in California or something like that, where you're trying to predict the price of the house, given stuff about the area, the number of bedrooms, bathrooms, stories, whether or not there's a main road, and so on. And you're trying to predict the price. And so notice that the price can technically range from negative infinity to positive infinity, I guess. And so that would make this a regression task. And let's say the area would be technically it would be like a continuous variable, right? So it would be a continuous feature. So all of these are features, but this is a continuous feature. The number of bedrooms, actually, there's an argument that this could be discrete. Technically, this could go up to infinity, but because of the practical purposes, we could consider this as, one, two, three, four, or five bedrooms or something like that. And so there's not like room beyond that, I guess. And number of bathrooms, same way, you can consider it as discrete. Over here, you can consider this as discrete because it's a yes or no question and a yes or no question over here as well. And then you would use all of this information that I guess you would know about the house in order to find out what the price is. Here you can see a slightly more complicated example. It's called MNIST digits. So this is just a bunch of handwritten digits, just like this. And they're in like a box format. And all of those pixels get turned, all of these pixels get turned into brightness values. So over here you can see 0, 0, 0, 0. And then over here you can see that there actually are non-zero values in this three shape. And so over here, what you would do is you would take this, and technically, these could all be treated as discrete variables or continuous variables. It's kind of a gray area over here. But basically, one thing that you could do is, so this is actually, I think, a 28 by 28. Um, and this, so you would have like a 784 pixels over here. And so out of those 784 pixels, what you could do is you could have pixel number one brightness, pixel number two brightness, pixel number three brightness, all the way to pixel number 784 brightness. And then you could use that to classify whether or not it is some sort of digit, right? So what I can do actually is actually for the output, there can be 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 9. And since there are 10 options here, you can actually have 10 options over here. And just like before, let's pretend that this is 10. And like before, I can train multiple different classification tasks in parallel and then decide which one the digit is based on like the highest probability or something like that. Again, we'll talk about this more in detail. But this is an example of many to many, sort of. Here you can see a slightly different version, which is fashion MNIST. Instead of digits, now you have different types of clothing. And yeah, I guess this gives you a pretty good example of, what are the kind of data sets that are out there and stuff to play with.